Did some work in Chapter 7. I'm not sure how many videos there will be in Chapter 7. I expect 3, no more than that. Video is September 25. Worked on 38 problems. So now I'm up to 1,265 problems. And yeah, so I read these first 2 sections. So then for the book, it's section 7.1, orthogonal matrices. Very straightforward work, nothing special really to see here. Just a continuation of work that's been going on in previous chapters. My voice is a little off. I'm running through COVID, so it's no fun. But either way, you know. Section 7.2, orthogonal diagonalization. Yep, more of the same. The thing that I like about the problems now is they require you to think about which way you want to go. It's not a simple route, and I'll show you when I show the problems that actually there's some branching that you need to do to get to the final answer. This very neat result that does the spectral decomposition of the matrix. So this matrix is now equal to the eigenvalue times the unitary, the normalized, I should say normalized vector for that eigenvalue and the transpose, and it works out just great. I mean, that's just the way it works. Yeah, very straightforward as far as the book content is concerned. Now, in this case, I have not, in other subjects that I've worked through, I fill these books, these notebooks, with all kinds of content from handouts because there's something interesting, something added. I have not done that with this first go at linear algebra because it's just like, just the facts, figure out how to do the problems, keep going. But anything that is SVD, singular value decomposition, and of course, Kalman's making a pun, singularly valuable decomposition, but it's really singular value decomposition. Anything that's SVD, I'm focusing on for my learning, my linear algebra learning. Of course, once I move on to FIS, the theory book, I'll move on to other things that are more of a lead-on to abstract algebra. But for this go, SVD is the way to go. I skimmed through this now, but I know there's a section on SVD in Chapter 9, so I'm going to come back to this handout in much more detail when I read that and when I work on problems in that section. So onto these first 2 sections. Of course, I'm halfway through 7.2. But this covers the reading as well. So the reading for 7.1, yeah, and then started working on problems. Just going back to diagonalization, you're setting up your P matrix, and then you do the transpose, multiply it by A and P, and you get the eigenvalues. You just do. So there's a lot of that type of calculation in this section and the next. Of course, some arithmetic problems here and there where I make a mistake. For section 7.1, I was able to figure out a couple of the proofs as well. And I think I got them all. I got all the true false, which doesn't happen that often, as you guys have seen. There's some times where I might as well have flipped the coin for the true and false. Then orthogonal diagonalization, the reading for it. And of course, and I've shown this before, when I read the examples, I actually do all the calculations for every example. I don't just take whatever the book says. And I believe that earlier in the book, I found a mistake in one of the examples. I believe that to be true. But yeah, just work it all out for myself, for my own learning. Then spectral decomposition. Then some theorems at the end that I haven't gotten to do problems for, and then just start cranking through the problems. I was very sloppy in the first few problems, made some really dumb mistakes, but then I got going and I got my rhythm. So for example, one of these problems, problem 5, I just got it completely wrong when I did it, and of course, and then so I wasn't happy about that. Then I think by the time I got to problem 11 is when I got my rhythm, and all the problems that I did after 11 are correct by the book, so that's pretty good. And so the path is you solve your eigenvalues, you make sure that they work, that they're correct, then you get your vectors for the eigenvalues, you have to normalize them to get your P matrix, and then if they're not normalized, if there's 2 for the same eigenvalue, you have to make sure that they're orthogonal. And if they're not, then you have to do Gram-Schmidt on them and get those 2 to go into the P matrix. Otherwise, what you put in the P matrix is not going to work. It's not correct. So for example, here, -1, 1, 0, -1, 0, 1 is not 0. So you need to use Gram-Schmidt. So you do Gram-Schmidt, and then you get your vectors, normalize them, and that's the correct P matrix. And sure enough, you end up with your eigenvalues. Yeah. So that's how far I've gotten into section 7.2.